All right, multiplicity. Multiplicity is what I just kind of showed you with that. We have two types. We have an even multiplicity, okay? And an odd multiplicity. Even would be like x squared, x to the fourth. Odd multiplicity, of course, would be x to the third, x to the fifth. They behave differently on a graph, okay? So evens bump the graph. Odds will cut through like we just saw on that one. So for example, we have, it can come from the top or the bottom. It comes up and touches there. That's going to be an even. Most of the time it's 2, okay? Multiplicity of 2. Occasionally a 4, but Mary, not that often. Odds, as we saw in that previous problem, they come down and they have this little hook. Most of the time, our odds are going to be a multiplicity of 3, not very often a multiplicity of 5. How you're going to discover this is by using your graphing calculator, okay? So you do need that. You can tell what's going on by looking and seeing at your graph. If it bumps, you got a good chance it's a 2. If it cuts through with a hook, you got a good chance it's a 3. So there's your multiplicity. See if you can graph this one again. And see if you can get what I have there. X cubed plus 6x squared plus 12x plus 8. So clear out your y equals from the previous one. Put that guy in there so you can get that particular graph. If you have problems, let me look at it.
Why is my graph like that?
The window, Zoom 6. Change the window. Zoom 6 is the window change. No calculator. So grab one of mine when you come in.
Or it's Zoom 6, right?
All right, so if you got that, okay, we're going to do this process for about 6 or 8 days. What I'm showing you today, we're going to do for the next 6 or 8 days. So I'm suggesting you really try to hang in there today if you don't feel like paying attention, but try to. Okay, look, this has a power of what? Degree of what, folks?
3.
How many roots do we have to find? 3. Does it look like we found them already? It does to me. Look, it comes down and it hooks through. It looks like, if I'm guessing, I'm going to say x equals -2 and has a multiplicity of what? 3. Hopefully that totally makes sense to you.
Oh, that's all we have to do? I'm so confused.
Now, let's start. Now, I don't know that for sure. How am I going to find out for sure? Well, I'm going to use synthetic substitution to figure it out. So, I think it's -2. Let's check it out and see. 1, 6, 12, 8. 1 comes down, that gives me -2, that gives me 4. That gives me -8. That gives me 4. That gives me -8. Boom. There's one of them. But how many do I think it is?
30.
3. So I'm going to continue doing synthetic on it. Since I got it nice and handy. Okay? -2. I'm going to use what's left over. Okay? 1 comes down, -2. That gives me +2, that gives me, I still got another one, don't I? There's number 2, I gotta try it one more time. Gonna use what's left over. 1 comes down, -2, boom. So what did this part do, the red, blue, and the green? What did it do? It proved that what? It proved that my guess was right. It proved what I saw in my graph is true. X equals -2 with a multiplicity of 3. What does that mean? That means this, okay? X plus 2 x plus 2, x plus 2. If we were to FOIL that all out, what would we get? If we were to go backwards and FOIL all that out, what would we get? We'd get that right there, wouldn't we? Is that sinking into you? Do you understand? You should by now, because we've been doing this a little bit. Question?
How'd you get the -2? Mine doesn't have the little thing like that says it. How'd you get something?
You can hit trace, second trace, and do an intersection on the calculator.
Okay.
Second trace, there's an intersection menu part
Okay.
Is it just where it hits the axis? Though?
where it hits the x-axis.
Mine says 8.
All right. Just take a look at this one. Don't put it in your calculator. What do you think? Just by visual, we're not gonna even check it, just visually. Or does it look like, how many roots do I have to find? 4. Is anything sticking out at you? Sure, x equals what? -3. Does it look like it goes straight through or does it hook through? So that's gonna be a multiplicity of what? Okay? Do we have any others where it looks like it's going? Yeah, right here. What's it look like it's right there? What's that? 1. So it looks like x equals 1. It doesn't have a multiplicity, it goes straight through. You see the difference? I'm not gonna check them all, but how can I check them? Do synthetic substitution on all those and get a remainder of, and I would know that those are the 4 roots. Now, one of them has a multiplicity of 3, but those are the 4. How we doing? Everybody okay? All right. Next part is the rational root theorem. And this is really what we want to get to today. It states that if a polynomial has integer coefficients and every rational component can be found by where P is the constant factor, your last one, divided by all the factors of Q. I don't think you need to write this down. We're gonna put this in play. I see some of you daydreaming right now, and it's not gonna be good. If we have an irrational root, we always have a plus or minus 1. There's always gonna be plus. Remember, this would be like A plus or minus the square root of B. It'd be like 5 plus or minus the square root of 3. Remember, there's always a pair of irrationals. All right, let's dig right in with this first problem. This is a process that we're gonna follow, again, for about the next 10 days. Step 1 is graph it, so go ahead. Graph this. See what it looks like. Step 1, graph it. How many times is it? Probably, it might cross how many times? No, most at 3, Logan. Why? Because the degree here is a polynomial degree of 3. So we're looking for probably 3 roots. Everybody see them? Does it cross 3 times?
Yeah.
Does it? Okay. Step 2. We're going to list the possibilities. Okay? Now here's what that rational root theorem says. All the factors of 4, which would be 1 times 4 and 2 times 2, and they need to be plus or minus. So I'm taking the factors of 4 divided by the factors of my lead coefficient, which would be factors of 2 would be 1 and 2.
What does number 2 say? List what?
List the possibilities. It's not real clear there, is it? List the possibilities. So what are my possibilities? 1 over 1 would be plus or minus 1. 1 over 2 would be plus or minus a half. 4 over 1 would be plus or minus 4. 4 over 2 is plus or minus 2. 2 over 1 is plus or minus 2, but I already have that one. I'm not going to write it again. 2 over 2 is plus or minus 1. I already have that.
How did we get the feeling?
Leak coefficient, 2, and constant, factors of. How do you get 4? 1 times 4 and 2 times 2. That's all, factors of 4. How do you get 2? Factors of 2, 1 times 2. It's just the factors of those. Then I said 1 over 1 is 1. 1 over 2 is half. 4 over 1, plus or minus 4. 4 over 2 is 2. 2 over 1, we already have that, 2. And 2 over 2, we already have that 1. So how many possibilities are there? 1, 2, 3, 4, double that, there are 8. Went to Red Lobster last night. Hello, is everybody listening still? Now, back in my day, in 1924, when I was in your seat, okay, and I had to do this, my old codger math teacher told me, all right, start doing synthetic division. Figure out how many roots do I need? 3. Okay, I didn't have that graphing calculator.
How'd you graph it?
I didn't. I used this process.
So you
Okay,
don't.
then I had to guess. I just had to start doing it. I could end up doing all 8 of them before I got the right one. You with me? Okay, but you are going to graph it, then you're going to use your visual to, cut this down. Does it look like it crosses at any of those spots? Look on your calculator now. 1, half, positive, negative, does it look like it crosses any of those?
No.
Well, it has to. It has to.
-1.
-1.
Does it look like -1?
-1/2.
I think -1/2 sounds like a good deal to me. Let's try -1/2. Now, how are we gonna know? We're gonna use what? Synthetic division. Synthetic substitution, my bad. All right, so what do we got? 2, 3, -10, and -4.
-3.
Folks, let's go. Did I mess up?
-3.
Oh, yeah, -3. Let me go back and talk about this for a second. How many roots are we trying to find? 3. You understand these are the possibilities. I don't want to do it on all 8 of those. I want to eliminate some of those. How am I doing that? By looking at my graph on my calculator. We're thinking it might be that, so let's see. 2 comes down, right? That's going to give me -1. That gives me -4. That gives me +2, which gives me -8. That gives me +4. And I'm pretty happy about that because that is one of my 3. So instead of having to do it on all 8 of those, I was able to use my calculator to help me. Now, is we always going to get it right every time? Probably not. What are we looking for? A remainder of 0. Second point today is, and you're going to need to mark this down if you can, is we found once we got that first root, we're down to what now? We're down to what? X squared plus 4x plus -8 equals 0. We're down to our favorite things. What are those? Quadratics. Okay? Everybody got this? Listening? To get it to a quadratic, you either got to complete the square or use the quadratic formula to get the last roots, because there could be irrational roots, there could be complex roots. You might be able to factor it, but as we investigated our graph, did it look like it went nicely through 4 or 2? No. So the last 2 we're going to have to use quadratic or completeness. I'm going to take out 2 because that'll come out of everything. So I just factored out GCF of 2. So now I'm thinking of this trinomial here. I'm thinking I'm going to take a quick look at factoring. Factors of 4 with a difference of 2? No, there isn't any, is there? So what are my options? Quadratic or complete the square? Which one does it look like? Well, the middle term's nice and even too, so why not don't I complete the square? Now, heaven forbid, we're expecting you to remember something from chapter 5. Yeah, we are. But that's what you gotta do. We're trying to find those last roots. We have x squared minus 2x. I'm gonna take the 4 to the other side, it becomes positive 4. So I'm moving this 4 over, right? Complete the square now. I'm going to end up with plus 1 here and plus 1. There's my perfect square trinomial. Always x, always that sign, always half. What do I have over here? It is 5. Next step, square root x minus 1 equals plus or minus square root of 5. And I'm down to my final 2 roots that I found. Here's my first one. My other 2 are going to be this. I got to take this to the other side. The other one's going to be x equals. If I take 1 to the other side, it's going to be positive plus or minus square root of 5. Root number 1, root 2, and root 3 of my degree 3 polynomial. There's a lot there. Yep. And if you're half in the bag today, you're going to be in trouble. We're going to do another one, so hopefully you can follow it. Why are we graphing it? So we can have a better idea of what to do synthetic division on. That's a simple term. Do you understand that?
Where do you get the square root of 5?
Completing the square. 4 plus 1. I added 1 to complete the square, make perfect square trinomial. 4 and 1 give me 5. Then I take square root of both sides.
So how come you can use synthetic division on, to find the other 3 on the other ones, but not this one?
Because I knew it was a multiplicity of 3, and I could just keep going, -3. That's a great question. He just asked a really good question, so I can tell you're engaged. Thank you. Yes, well, last time I did synthetic on that first set because I thought it was a multiplicity of 3, so I just kept going. We're going to get into some. We are going to be able to do synthetic to get irrationals, and you're going to get some irrationals at the end. The only way to get those is to do quadratic or complete the square. When you get it down to a quadratic, you got to go that route. Want to try this one? How many we got to find?
4.
Okay,
Oh,
got to find 4. Might want to put it in the graph. I'll list the possibilities, which are all the factors of 6, which will be 1 times 6, 2 times 3. Those are all plus or minus. Over the factors of 4, which would be 1 times 4 and 2. We are going to have a lot of possibilities, aren't we? In fact, I'm not even going to bother listing them. I'm going to let you look at your calculator. Listen, if you don't want to list them, you don't have to. You understand that? Why? Because you can just look at your graphing device and maybe come up with something that looks like we could do synthetic on and see if it goes through that. So we got 4 roots to find. Let's see if we can find them. As soon as someone gets a graph in there and give me an idea, I'll go ahead and list the possibilities down here. 1 over 1 plus or minus 1. 1/4 is a possibility. 1/2 is a possibility. 6 is a possibility. 6 over 4, we'll simplify that to 3 over 2 is a possibility. 6 over 2 would be 3 is a possibility. 2 over 2, oh my gosh. Plus or minus 2. 2 over 4 is a half, got that. 2 over 2, I got that. 3 over, I got 3. 3 over 4, that'd be plus or minus 3/4. Whew. And then 3 over 2, do we have that? Yeah, we have that. So 1, 2, 3, 4, 5, 6, 7,
in the right spot.
8, 16 possibilities.
-3/4 is not.
Is everybody kind of getting the idea?
Positive 2 is going.
I don't want to do it over all 16. I want to use my graphing calculator to eliminate some of those so I don't have to do synthetic on all 16. You get that? You guys, that's a luxury you have. What do you think?
Positive 2.
Positive 2. Let's take a shot. Positive 2. We got 4, negative 21, 18, 19, negative 6. What do we look for? Remainder of 0. Whoops, I already messed up. 4 comes down, that gives me 8, right? What's that give me? Negative 13, right? That's gonna give me negative 26, that's gonna give me negative 8, it's gonna give me negative 16, that gives me positive 3, that gives, hey, good call. I think I did my math right, did I? There's 1. So that's 1 of 4. We gotta find another one. Is there another one that looks like it goes through? We're gonna use what's left over here. Negative 3/4. Let's take a shot at it. 4 comes down. 4 times 3/4 is gonna give me negative 3. Is that right? And is it negative or positive? Negative 3. That's gonna give me negative 16. Negative 16 is gonna give me positive 12, I think. Help me if I'm wrong there. That's gonna give me 4 here. And that's gonna give me negative 3. Gives me 0. Woohoo! Number 2. Pretty good work right there, fellas, ladies and germs. We got lucky. We guessed the first 2 we come up with. How'd you know that? Looking at your graphing device. You eliminated some of those 16. How many am I looking for? 4. I've got 1 and 2. How am I always gonna get the last 2? I gotta use quadratic now, okay? So this is gonna be 4x squared minus 16x plus 4 equals 0. I need some room there, but I'll go back up a little bit. How you wanna go about that? Complete the square, quadratic, because I don't think it's gonna factor, but let's take 4 out. So 4 is coming out. We're left with x squared minus 4x plus 1 equals 0. Are there any factors of 1 that can get to 4? No. What's our only option here? My only option would be to complete the square. I hope that's yours. I think it's the easiest. Why? The middle term's an even number, isn't it? Try it. I know it's been a while. See if you can complete the square on this guy. Take the 1 to the other side. See how far you can get. I'll do it in about 42 seconds. We're trying to find those last 2. We had 16 possibilities. We used our calculator. We were able to narrow some down. We took great guesses because we got 2 already. Here's 1 and here's 2. We got it down to the quadratic, which is fantastic. We factored out a GCF of 4, and we're down to x squared minus 4x plus 1 to get our last 2 roots. I think completing the square is our safest option. X squared minus 4x. I'm going to take that 1 to the other side. It's going to become negative over there, isn't it? Middle term's 4. Half would be 2. Squaring would be 4. So I'm going to add 4. Add to the other side. None other than a perfect square trinomial. Always x. Always that sign. Always half the middle. I'm equal to what over there? Great. Take square root of both sides. I'm down to x minus 2 equals plus and minus square root of 3. Take the 2 over. It's going to become positive 2 plus and minus square root of 3. Root number 3 and root number 4 are both irrational. That's why it doesn't look like they go through nice little perfect numbers on our graph. They're irrationals. Warning, warning, warning. If you don't practice this, it's not going to happen. We're deep in algebra 2 now, folks. It's only getting harder. Third language is the hardest, I'll be straight up with you. We're going from this to logarithms to rational expressions. So whatever you got going on, try to put a little time into it. At least try to do the homework as best you can. We just have a couple problems to decide. Hope you do. I think it's page 442, 440 something, 442 or 443, 11 through 14. And see if you can try 21 through 22.